A very pleasant greetings. This is Helena from 2021 to 2023 batch. And my given topic today is one of the most abundant divalent cation. And then, whenever I used to read it, I used to hit a quote like, "A friend in need is a friend indeed." Hope I guess you can answer for this question at the end of my presentation. So, much further ado, let's get into it. So guys, any guesses? If you guess it is a calcium, then you are right. Yes, it is a calcium. Followed by sodium, potassium and magnesium, calcium stands fourth abundant divalent cation in our body. For better understanding, in a 70 kg human, it is contributing up to 1 to 1.5 kg of total body weight. So, much further ado, let's really get into its sources. So, how we are getting calcium? Yes, of course. Now itself, you will be getting that milk and milk products and fish in fishes, especially sardines, salmons, and surprisingly, it is also in vegetables like turnip, mustard, greens, broccoli, cauliflower, kale, and etc. So, where the tofu is the richest source of calcium. So, this is all we usually know about it, and in specific, so between 200 to 400 milligram of calcium is produced by 1 cup of milk or yogurt. So how it varies, it purely depends upon the breed. And sardines with bones, so our South Indian culture, we used to take it. So sardines with bones contribute about 400 milligrams for 3 ounce. Followed by it, there are several supplements, especially calcium carbonate is the best because its absorption rate is 39%, and at the least calcium monophosphate, which is about 25% of absorption rate, and in between is having like calcium lactate for 32%, calcium citrate for 40%, etc. So, these are all the sources which we are taking naturally and synthetically for our body to enhance the calcium. So now we have taken it up. What for we are eating calcium? Let's see it in detail. It is digestion. So imagine you are having a cup of yogurt on your hand and you are eating it. What is actually happens inside your body? Let's see it deeply. Actually, as you eat it, the calcium gets in and then it will get solubilized only if your stomach is in acidic condition. So, if not, then the absorption rate will be decreased. But you cannot say either in a way that the solubilization will completely help for the absorption, because this solubilization will produce some of the calcium which is free calciums, so that it binds to the phytate and oxalates and easily get out of the body. Now let's speak some advanced nutrition. There are two major transportation for calcium in our body. One is from vitamin D, which helps. So this is why I refer there, a friend in need is a friend indeed, because without vitamin D, calcium will be really tough to absorb in our body. And the second transporter is paracellular diffusion. So it takes place in our body when the calcium amount is larger in amount. So now let's see about the first transportation, how it actually works. For this we need vitamin D. So from the sunlight it reaches our skin, where our skin take it to the liver and there 25 hydrolysis takes place, and then it takes to the kidney through DBP, which is vitamin D binding protein. There it makes one hydrolysis happens, and then it forms 1,25 OH twice cholecalciferol, which is otherwise called as calcitriol. One of the magical process in our body, right? So after this calcitriol formed, it directly gets to the intestinal brush border and it's attached to the VDRE element, and from there the mRNA is transcripted for the calbindin, which is act as a wheel for a TRPV6, which is transient receptor protein B6, which act as a channel or a pathway for a calcium to get in easily. So through brush border, it gets in and it reaches the basolateral layer. So from there, it needs to get out. There comes ATPase. It is actually an ATP pump where the magnesium and sodium comes in and calcium goes out. This is one kind of transportation, and there is, as I said, another transportation is a paracellular transportation. So in this, it is actually happening in between the cell instead of through the cells. So it gets increased with the help of oligosaccharides, fructose and inulin. Actually, what the mechanism behind it is, the G protein gets open and allow the calcium to transfer. So this paracellular diffusion takes place in the jejunum and ileum, whereas the calcitriol diffusion takes place in the duodenum and proximal part of the jejunum. Now let's see what is making this calcium more and more interesting, because in this thing we should notice that the colon is also playing a major role. In colon, the bacteria will ferment the oligosaccharides, fructose, inulin and produces calcium, and it also ferment some of the fibers like pectin. Our body's colon is having a capacity to produce approximately 8 mg of calcium each day. It's a tidbit. So again, what I'm going to say is about how the factors influence calcium absorption in our body. Actually, how it done, all our life is having both good and bad things. So it's not always really relying upon a good thing or a saddest thing. Likewise, in calcium also, there is an inhibitor and also an enhancer. What are the inhibitors in the sense, as we talked in the starting of the topic, like phytates and oxalates will bind with free calciums and excretes. And again, what fatty acid do here? Actually, it's not for all the people. It's for some of the people with a condition called steatorrhea, which is a condition in which the people will have fat in their stools. So whenever they take calcium in this condition, it will combine with fatty acid and form soapy matter, so that there is no calcium absorption taking place. And the happiest thing, which is enhancers, is sugar and sugar alcohols. Lactose, especially in children, when they took breast milk, the calcium absorption is good because of the sugar and sugar alcohols. And then second is protein. Actually 40% of our body's calcium will bind with protein like albumin and goes for transportation. So protein is an enhancer, and it also excretes lot of calcium through our urine too. So I don't know where to put this, maybe an antagonist or an agonist, your choice. By now we have learned how it absorbs and what are the factors inhibit and enhance the calcium. And after absorption, what happens? Regulation, right? So regulation of calcium intracellularly and extracellularly. How it takes place? Let's see it in detail. You are having lack of calcium in our body, so that your extracellular calcium concentration regulation should get activated. What happens? So it is a cascade of process. As soon as the blood concentration of calcium goes down, it goes and directly hit the thyroid gland, where it having a calcium sensing receptor, so that from there the chief cells produces parathyroid hormone. This parathyroid hormone goes to the kidney and asks the kidney to produce 1,25 OH twice cholecalciferol, which is our calcitriol, as it goes directly to the intestine for the formation of calbindin. And this parathyroid hormone also goes and hit our bone, where the osteoclast, clast for cleave, and the osteoblast will be a crystalline bone. So this amorphous bone, which is an osteoclast, starts to cleave and gives resorption of calcium to our blood. Through resorption, bone first osteoclast starts to get deteriorate, and then it goes to the osteoblast cells. So it acts like a shield for osteoblast. And finally, after overall, once the calcium goes up, it goes and signal to the parathyroid hormone to decrease, so that it will produce signal to the kidney to produce 24 hydrolysis to control the calcium level in our body. So this is what takes place extracellularly. Now let's see what is taking place intracellularly. Low free calcium concentration is maintained inside the cytoplasm of the cell through depolarization or through the neurotransmitters, and the extracellularly the concentration of calcium is also managed within the cells by giving out of calcium and getting inside of magnesium or sodium through ATPase, which is an ATP pump. And especially in nucleus, calcium will go and store. So from this we can say, in the emergency situation, the mitochondria, which is the powerhouse of the cell, and the endoplasmic reticulum will start to give out the calcium by pump and secondary messengers. And if there is lot of calcium, again this endoplasmic reticulum will give out one magnesium and takes in one calcium. So this is how the mitochondria, vesicles, and as I said before itself, nucleus will also capture calcium within it. So how does it get stored inside the mitochondria and endoplasmic reticulum? So in the endoplasmic reticulum, it goes and bind with another protein called calquesterin and stored inside the mitochondria. It goes and attached with a phosphate and gets stored. So this is how calcium is regulated inside the cell. It's an important part of our yogurt in our body. As we eat it, we have undergone lots and lots of things like digestion, absorption, transportation by escaping from the inhibitors and shaking hands with the enhancers, and then extracellular regulation, intracellular regulation. After all this whole process, what calcium going to do? Yes, maintenance and functions of our body. As we all know that, what for calcium is used in our body? Yeah, I get lots of answers from you. It's bone. So for the bone formation and teeth formation, 99% of calcium is used. Especially it is called as bone mineralization in case of bone, and a teeth formation in case of teeth. In specific term, about 60% of calcium is used for bone and balance 40% is for teeth. Now we are going to concentrate on that 60%. So remember these two words, osteoblast and osteoclast. I have introduced it to you in the extracellular. Now we will be dealing it somehow deeper. So what's actually happening? Just imagine your bone with outer cover and inner layer. So inner layer is very strong, which is crystalline, and the outer is amorphous. So the outer is called as osteoclast and the inner layer is called as osteoblast. So C for cleave. Amorphous can be easily cleaved. So what this osteoblast used to do is, it used to produce some protein ground matrix and surrounds it. So it used to embed protein out of it to make the bone to get more mineralized, and in that osteocytes will be formed. So this osteocytes is used to maintain the integrity of the bone matrix. And osteocytes, osteoclast, and osteoblast. All three are very good friends, so they used to communicate with each other through canaliculae. In spite of these three, there is a fourth cell type lining, and that is called as periosteum. And in term, imagine it as a flat cells which surrounds your osteoclast again, and this is direct, which is having a direct contact with that calcium sodium potassium pump, and then the PTH responding for PTH hormones. So all these things, bone is not actually getting in direct contact, but the periosteum is acting as a frontline man to accept it. So let's see some more details about osteoblast cells. So it secretes some substance onto the bone surface which helps to precipitate and deposition of calcium and other minerals like phosphate and magnesium to make the bone more rigid and strong. And it also stops osteoblast from getting cleavage, and that enhancing the bone mineralization. Now let's see what is osteoclast. This type is actually what I said, it used to get cleaved easily, and for this resorption process it's not present in all of the cells, but it is present in a specific area, especially macrophage MCSF like colony stimulating protein, and then it is also present in a receptor activator of nuclear factor KB ligand RANKL, so rankle. So from binding to this receptors, it used to stimulate the periosteum for the cleavage, because it used to secrete lots of enzymes like citric and lactic acids, and then enzymes like protease and hydrolase, which used especially for breaking of bone. In another term, resorption of bone. It also contains lysosome, which is release these acids and enzymes. So from this, you could have a basic understanding of what is osteoblast and osteoclast and how does it work. So this is how our bone mechanism takes place. As soon as the PTH comes and hit, the osteoclast will first respond in spite of osteoblast. If it is not maintained properly, then it may lead to the toxicity and also the deficiency. So what happens in most of the cases in India, especially most of the people are subjected to osteoporosis, and in this case the resorption of a bone takes place in an amount which is uncontrollable. Balance 1% of the non-osseous calcium, which is not used for bone, is used for another functions in our body like blood clotting, nerve conduction, muscle contraction, enzyme regulation, and membrane permeability. Though it is in a very small amount, it is doing large amount of things in our body. So at first, through nerve impulse, it actually making the muscle contract. How in the sense, as it enters, the increase the permeability of nerve ending to calcium will enter and trigger the acetylcholine. So this acetylcholine goes and trigger the increase of sodium and potassium by binding into a receptor. So this conductance will lead to an influx of depolarization, which makes the muscle to contract. So this is how the nerve impulse and muscle contraction with the help of calcium taking place. Another function of the calcium inside our body is it triggers intracellularly. So the neutrophils activates and platelet phospholipase A2, which hydrolyze fatty acids like arachidonic acid from phospholipid in cell membrane. The arachidonic acid can be metabolized to form thrombosis, so here the blood clotting takes place. And another function is phosphoesterase. So it's one of the important function, like it gets hydrolyze the cyclic AMP to 5-AMP. So this depends on calcium. So the cyclic AMP formed from ATP by adenylate cyclase activate protein kinase, which influence intermediate metabolism. So this calcium activates protein kinase C, and this process is basically helps in made through the phosphorylation for this phosphorylation enzyme to activate or inactivate metabolic pathway. And then if calcium increases intracellularly, it goes bind with the protein calmodulin, and just having the capacity to hold 4 proteins, which leads to series of actions like calcineurin, a phosphate that dephosphorylate inactives calcium channels, as we see in ER itself, like in endoplasmic reticulum, and also in mitochondria it goes and attached with phosphate. So it if it is larger in amount, this calcineurin, a phosphate that dephosphorylate and goes and attached with calcium channels. This is what happening, and then myosin light chain kinase taking place, and then phosphorylase kinase activates. Then another protein is troponin C. It stimulates the skeletal muscle by nerve conduction through increase of calcium concentration. This calcium binds with troponin C, which is having the capacity to hold 4 calcium. So once it is holded, the conformation gets changed, and it leads to the interaction of actin and myosin for muscle contraction, and the calcium plasma level gets repolarized. This calcium pumped back to the endoplasmic reticulum, which if there is no need, this myosin and actin will no longer active. There is a need, then it won't no longer inactive. So this is for troponin C is used. So this calmodulin and troponin C are the 2 proteins which helps for the calcium to regulate our body function and maintenance. So it's already time to excrete what we take in. A cup of yogurt? Okay, fine. So in fecal matter, it excretes about 45 to 100 milligram per day, and in urine, it purely depends. So if you are already having a lack of calcium in your body, then the PTH works on potassium, sodium, boron, magnesium. All these will work on to keep your calcium inside the body itself. So if it happens, then the calcium won't that much excrete in the urine. But if you are having an abundant amount of calcium in your body, then it will excrete with sodium, and protein also leads to excretion of calcium in urine, and caffeine intake also leads to excretion of calcium in urine. So these are all some of the things, and if boron and magnesium combine with each other, it will make excretion of calcium. But if they are not combined, if they are independent, or if they are isolated from each other, then our calcium is safe. Approximately about 240 milligrams of calcium will be excreted through our urine. So this is all about excretion. Let's talk something about deficiency. What happens if no calcium? Of course, bone and muscles gets affected, rickets in children, and lower level of free ionized calcium in blood will lead to hypocalcemia, tetany. So muscle fail to relax, numbness, so muscle pain, muscle spasms, all these will happen. In adults, especially osteoporosis, as we discussed in our above sections itself. Then what happens if I take a lot of calcium in my body? So the upper limit itself 2500 milligram per day, so it is tolerable. If it goes beyond that, it will lead to milk alkali syndrome. The increase of calcium intake will solve the soft tissues. As I said, the bone should not get too much hard and too much soft. So it's another case. If it gets too much hard, the bone gets calcified, so that the along with alkalosis, due to this constipation occurs. So a large amount of ingested people with idiopathic hypercalciuria increase of risk in kidney stones also. So too much of anything is good for nothing. So this is applicable for all our body's vitamins and minerals. A very big thank you for all those who heard this video till this end. Hope you all had a good learning time, and I wish each and everyone to have a good, healthy and happy life.